All right, we're to the third part, and we're to the how-to. This is how we're going to do it. So we still got our definition hanging out. The limit as x tends towards a of f of x is equal to L, which says for all epsilon greater than 0, there exists a delta greater than 0 such that if we have that 0 is less than the absolute difference between x and a, which is less than delta, then we can know for sure that the absolute difference between the function and the limit will be less than some number epsilon. Some positive. Okay. Let's look at our first example. Now, this is how I want you to do this. You can do it a different way, and if you find delta epsilon examples through another instructor, a different online resource, maybe you've learned this before from a different teacher, I know how to read these. I know all the different languages. There's a lot of different ways we can write these. But they all basically follow the same thing. So if you're going to use a different method than I do, please check with me and make sure that you're doing it right. Because when I grade it, I can read and I can tell whether they're right or not, even if you're doing something different. So please follow along, because there are proofs or a personal thing, and it depends upon who's writing it as to how you can do it. So I'm going to break mine down in a formulaic 1, 2, 3 step way of doing it. So step 1. Now this is, I don't give a shit which way you do it. You need to show me this. This is it must be done. And we want to rewrite this with all our x's, a's, f of x's, and l's. And there's our first step. And we say, all right, well, our a is 2, so it's the absolute value of x minus 2 is less than delta. Then I write an arrow, I don't write that, and let's say the difference between our f of x, which is 3x minus 1, and our L, which is equal to 5, is less than epsilon. So there we are. We're ready to go. We have our conditions written down on our example. So there's part 1. Now these will be a 10-point problem on your test. We work 10 points. That would be worth 3 points right there. Not even writing the rest of the proof, you could at least get a 30% on it. Now step 2. So I actually to write this, and you don't need to write numbers in this little 1. I'm just showing you that this is our first step. So our second step is we want to go find a delta. We want to find a delta. But how we do this is we never mess with it, at least in the way I do it. I never mess with this. I only mess with this. So here we go. Let's go find an appropriate delta. And we saw it in the last one a little bit. So we're just going to write this down. The absolute value of 3x minus 1 minus 5 is less than epsilon. And you could have cleaned this up. But I want in the first step, I want the f of x and I want the L. On this step, you could combine them. 3x minus 1 minus 5. But I'm going to do it right here. So I'm going to move down. I'm just going to move down. I'm just going to do a logical progression below it. Not equal signs, just a logical progression. 3x minus 1 minus 5. That's the same thing as 3x minus 6, correct? Correct. Cool, now let's write it again. And we're going to keep going down. Now let's factor that 3 out. Well, that's 3 times x minus 2. Well, let's get that constant the heck up out of there. And yank it out to the front. Because the absolute value of positive 3 is just 3. If that was a negative 3, you'd pull it out and it'd still be 3. Which is less than epsilon. Cool. Now, let's do this. Let's divide by 3 on both sides. So we can say that the absolute value of x minus 2 is less than epsilon over 3. Shit. Neato. But what pops out every single frickin' time, if it works, is look right here. The absolute value of x minus 2 is less than delta. The absolute value of x minus 2 is less than delta. Oh, I think we found delta. So unlike the last example where we found it to be a number, in this example, we're going to find it to be in terms of the epsilon. So if you tell me you need to be within 1 millimeter output, I'm like, oh, my input needs to be within a third. You tell me the output needs to be within 6, well, 6 divided by 3 is 2, so my input needs to be within 2. So this works for any and all. So we did it. We found step 2. We did part 2. We found delta. Yay, we found delta. Now the third step. And this is what we call proof. Now, this is where I didn't understand it for a long time. I'm like, what the hell? We've already done all the work, by the way. You've already done all the work. In step 2, now we're just going to confirm that what we've done is correct. And this is weird. So we are going to rewrite something here. I'm just going to write f of x minus L. I'm not, without the epsilon, no epsilon there. It's going to be there at the end. Now, this is weird. I'm not going to move this way. Like we could do equals and this. I have to move down. Because when we do algebra and we do numbers, move down. Don't stop doing math left to right. Sometimes if it's something quick and easy, don't do math left down. Go down. Then you can read what's up there. You might have been able to pull it off in algebra and you're like, no, I do it this way. Cool story. Everybody's told me that when they start off with me in calculus, that thinks they're going to do it that way, and by the time I see them in Calc 2, they have completely changed. By the time they get done with Calc 1, if they pass, they change. If not, they fail. But maybe you're different. Maybe you're that special flower. I don't know. Work down. All right, so I'm going to use an equal sign here. And we can jump some steps. Like, watch this. I'm going to be like 3x minus 6. And this is equal to 3 times x. Do we know where this is going? Look, it's the same freaking steps we did over here. So you wouldn't need to actually write the second or the third. You could just jump all the way down to this fourth line, if you like to. And just go, this is the same thing as 3 times the absolute value of x minus 2. Okay, now here's where shit's going to change. What do we know about the absolute value of x minus 2? It's less than delta. It's less than delta. So we're going to write it in this way. Real big. This is so important. This is a minus 2 if you miss it. Is this less than symbol? What's up above is less than 3 times, not x minus 2, but that delta. Because, let's look at it side by side. It's easier to see this side by side. That's what I just wrote in this line. Now what if you got rid of divide by 3 on both sides? The absolute value of x minus 2 is less than delta. That's just what we wrote there. So there was that next step. That less than symbol, I'm telling you, I'm staring at it. I'm looking at it. When I open up your test and I look, I go straight to that. Where's your less than symbol? And now we can use an equal sign because, well, shit. 3 times delta? Delta is equal to, oh shit, that's epsilon over 3. We found it from up above. And then what's going to end up happening here? It's going to go, hiya, hiya, and it's just going to equal, oops, don't want to get that far, is equal to epsilon. We just proved it. We just said 3x minus 1 minus 5. Now look at this, equals, 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 oh, less than, equals epsilon. Oh, we just showed that the difference between f of x and L is less than epsilon by plugging it back in. If you get that first time try, you're a beast. Most of us need to see it over and over and over again. But that is what's going on. That's how we solve one of these problems. Cool. Let's do one more. I just got another one. Let's change this one. I don't like this problem. I'm going to change it up. We're going to do another. But I'm going to go fast this time. The limit is x. Let's go to a different number. Let's go to x. Let's go to -1. Let's call it, I don't know, 4x minus 3, or plus 3. There we go. 4x plus 3. So that's what? That equals -1. Let's call it plus 5. Let's call it plus 5. So then it equals 1. There we go. Okay. Limit is x tends towards -1 of 4x plus 5 is equal to 1. It's true. It's freaking true. So we're going to write in our first step. All right. So the difference between x and a needs to be less than delta. And you could just write x plus 1. If you weren't watching, I'd just write x plus 1. I wouldn't write that shit. And then we're going to say that that implies that the difference between our f of x, 4x plus 5, and our L is less than epsilon. Bang! There's our first step. Now let's go find delta. So we're going to take what's on the right. We'll take what's on the right, and we're going to play around with that first, right? We don't dick around with the deltas. Let's get it. So we say, all right, we're going to rewrite this in 4x plus 5. And now let's just do it. Plus 5 minus, that's 4x minus 4 is less than epsilon. Look, I did a step. A little step right there. So now, maybe you got brave and you just ripped out that, you ripped out that 4 in one step, and you're like, I don't want to write 3 steps. This is too much. All right, you just got down and you only did it in 2 steps. I would be fine with that. That's all good. Now let's divide that 4 over to the other side. Let's divide that 4. Oh, shit. Did you see the sign there? Did you see? 5 minus 1, that's plus 4. That's plus 1. That's plus 1. Come on. We all make mistakes. It happens. Keep an eye on yourself because we're not perfect. Then we say x plus 1, the absolute value is less than epsilon over 4. Like shit. But does that match with what's up top? Well, heck yeah, it does. That minus minus, no, that's a plus 1. Hey, shit, I think we just found it. I think we're ready to go. I think we found something that'll work beautifully for delta. I think we got it. I think we should just let delta equal, what did we find there? Epsilon over 4. Oh, by the way, what was the slope of that line, 4x plus 5? The slope of the line, 4x plus 5. That's 4, right? And we're epsilon over 4. Oh. Hey, what's the slope of the line, 3x minus 1? I'm curious. I'm not sure what the slope of 3x minus 1 is. And then what was our delta? Epsilon over 3? Oh, neat. Cool. That's probably a coincidence. All right, cool. And now we go to our third step, which is actually to prove the dang thing. So let's do our proof. So we're going to write in our the difference. That's 4x plus 5 minus 1. But we're not going to write in the less than epsilon here. We'll do that at the very end. Remember, we're going to go down. This is weird. Now, if you want to go left or right on this one, that one's fine. I don't mind on this sort of because it makes sense going left or right. But I want you to get used to going down. So this is 4x plus 4. Now, this is where I'm just jumping. I'm going to just jump right to there. I'm not going to do the whole frickin' rigmarole. I'm going to take 4 times x plus 1. But here comes the weird. We're about to sub in, kind of. Big quote. Sub in for that absolute value of x plus 1. So we're going to do this. Boom. Because that x plus 1 absolute value needs to be less than delta. Not equal to it. Less than that delta. So we go less than 4 times delta. Now we can use equal signs the whole way through. We're like, well, delta, we found it to be epsilon over 4. Oh, how freaking convenient. That shit just cancels right out. And it equals epsilon. Oops. No, and it equals epsilon. Boom. Therefore, I didn't do it on the last one. I forgot to do it. I didn't finish the problem up. The limit as x tends towards negative 1, 4x plus 5 is equal to 1. Boom, and we proved it. And we proved it. I forgot to do it on the other one. Did all this freaking work and I forgot to state it. That's the best part, is saying it's the freaking end. Once you get to the end of this one, you just go back up and you state that that is true. There we go. So there's our delta epsilon proofs. This is how we do it for a linear case. I'm going to be back with a couple of other cases, which are a little bit more involved. One of them, I won't test you on it, but it is in your homework. And we'll have another one that's what we call a perfect square. Perfect square. It'll work out super nice. So we'll see you in the next one.